Hello, my name is Roberto Flores, and this is my Mechanical Engineering Freshman Lab 2 design project video. The animal which I was assigned to was the butterfly. The concept of my design was to simulate butterfly behavior. Specifically, I wanted to do this in two ways. Firstly, I wanted to simulate the flight of a butterfly by having it flap its wings if you got too close. Secondly, I wanted to simulate a main part of its life cycle, the cocoon. If the cocoon were touched, then an alarm would go off, signifying that the butterfly is best left alone in this state. I used two sensors in my creation, the first being a joystick and the second an ultrasonic sensor. I used a singular motor in my creation, the Dagu Robot DG01D 4.5 volt hobby gear motor. Personally, I found this motor in my basement. However, you could buy two of them online for about $5. I integrated sound into my project through the use of the joystick and the buzzer. The interaction begins with the cocoon. As the cocoon is touched, the joystick moves, and as the joystick moves, the buzzer picks up this interaction and sends an alarm out. Three new components were used from the Elegoo kit: the ultrasonic sensor, the buzzer, and the joystick. The project was originally meant to be completed in groups of 3, however, due to the outbreak of coronavirus, this was no longer possible. When the project requirements were revised, I decided it would be best to take a small part of what we were originally intending to do and to complete it myself. However, my instructor, Dr. Mera, advised me that I had bitten off more than I could chew. As a result, I toned back my plan and decided to focus mainly on the butterfly's flight and the cocoon. When the project was revised, the budget was dropped, as well as the availability of Arduino resources. Now, instead of having 3 kits to work with, we only had 1. In addition, the budget was reduced from $50 to only $10. This meant that the original mechanism that we had planned for the butterfly would not work due to our decreased budget and Arduino resources. Therefore, the design needed to be changed. Initially, I was uncertain as to what I would do. I researched many different ways that I could get the butterfly to flap its wings, and in the end I decided on a cannon follower system. I began building with a cardboard prototype. This acted as my proof of concept. When I determined that my idea had merit, I moved on to creating a wooden version, employing some key takeaways I gathered when making my cardboard version. This wooden creation became my final product. As for the materials of this project, I didn't use anything that I didn't already have in my own home. My father, as a former electrician and general handyman, had a lot of wood I could use. General scraps from projects long gone. He also had the gear motor, which became essential to my project considering how much torque it required. The main problem I encountered in my project was friction. When using a system with camshafts, friction becomes a very important factor. One big problem I had initially was that when the rods were pushed up by the cams, they refused to come back down due to the friction between the rods and the top pieces. I solved this issue by attaching a nut to the bottom of the rod. This would allow gravity to pull the rod back down. The trade-off was that now there would be more torque required to move the camshafts. There was, of course, the issue of friction between the drive shaft and the walls of the mechanism. This was solved by making the diameter of the holes in the wall a certain degree larger than the diameter of the drive shaft. There was also the issue of attaching the motor to the drive shaft. However, luckily for me, the motor didn't have a perfectly cylindrical drive shaft, but rather it had 2 flat edges. This enabled me to cut a slot in the drive shaft that the motor could grab onto as it turned. Another big issue I had was the alignment of the rods. They had a tendency to turn and move as the cams rotated. I solved this by adding another shaft. This second shaft wasn't attached on the bottom end, it was only on the top. This meant it could move freely and it wouldn't hinder the up and down motion of the rods. However, since it was still attached at the top, it would prevent them from moving sideways. That was my creation. I hope you enjoyed, and thank you for watching.